Hello students, I am Sandhya, chemistry teacher. Today I am going to discuss about the concentration of solutions. We use various ways to express concentration, such as concentration in terms of weight by weight, or mass by mass, or mass by volume, or volume by volume. Sometimes we also express in molarity, and we also express it in terms of normality. So today we are going to discuss only about normality. So before that, if you want to understand normality, first you have to understand how the solutions which we prepare, like an acid, a base, or salt. If these solutions are prepared in normal solutions, how do we prepare it? For that you have to understand the concept of acidity of base and basicity of an acid. So first we'll discuss about acidity of base. Acidity of base means the number of replaceable hydroxyl ions. How do we say this hydroxyl ions? Say for example, you have NaOH. If it dissociate, it forms Na plus and OH minus ion. So as you can see, NaOH has one OH and it is giving one OH. Whereas in case of magnesium hydroxide, it dissociates to form Mg2 plus ion and 2 hydroxyl ions. Similarly, aluminium hydroxide dissociates to form Al plus 3 and 3 OH minus ions. As you can see, the number of hydroxyl ion vary from one base to other. So, depending upon the number of hydroxyl ion coming out when the base dissociates in water, we call it as acidity of that base. So, with these examples, we can say NaOH has the acidity of 1, magnesium hydroxide has a acidity of 2, and aluminium hydroxide has acidity of 3, right? Similar to acidity of bases, we also have basicity of an acid. So that is means number of replaceable. In case of acid, it will be H plus ions or protons. Say for example, you have HCl. It will undergo dissociation to form H plus and Cl minus. H2SO4, it forms 2H plus and SO4 2 minus. In case of phosphoric acid, it forms 3H plus and PO4 3 minus. As you can see, the acids, depending upon the number of protons produced when they undergo dissociation in water, we say the basicity of HCl as 1, basicity of sulfuric acid 2, and of phosphoric acid 3. So this is how you say acidity and basicity. But in case of salts, it depends upon the number of positive charges present. Say in case of NaCl, number of positive charges will be 1. So it will be 1. So in case of ammonium sulfate, it will be 2. Right? So like this, it changes for the salt. Now how this is related to normality? So for normality, we take, it is defined as normality of a solution is equal to number of gram equivalents of acid, base or salt by or in 1 liter of solution. We know molarity. What is molarity? That is number of moles per liter. Moles per liter of the solution. Whereas in case of normality, it is the number of gram equivalents. So to find the number of gram equivalents, you need acidity or basicity or number of positive charges. How do you find number of gram equivalents? Number of gram equivalents. Can you follow, students? Are you able to follow? Yes. So number of gram equivalents will be equal to molecular mass of the substance divided by acidity or basicity or number of positive charges. So based on this, we are going to find the number of gram equivalents. That will give you the normality. Usually the solution concentration will be expressed in normality when we need a highly diluted solution. So during qualitative analysis, we require only diluted solution. So to make it a dilute solution, we always go with number of gram equivalents. Usually equal number of gram equivalents react together. Equal number of gram equivalents of acid will react with same equal number of gram equivalents of base. So this will be easy for our calculation as well if you take the concentration in molarity, as it will be a equal number of acid base neutralization reaction. So how normality and molarity are related? Since we know molarity is nothing but moles per liter. Moles can also be described as mass by molar mass, correct? So how normality and molarity are related? Normality is equal to molarity into acidity or basicity. So that means the solution, if it is in a molar concentration, it is more concentrated. If it is normal concentration, it is diluted. If the acidity and basicity is more than 1. If it is equal to 1, then normality will be equal to molarity. How is that possible? So let's see. So for example, I have 0.1 molar solution of HCl. We know the basicity of this HCl is 1, right? So what will be the normality of the solution? So normality we don't know, we have to find out. We know the molarity, we have the formula molarity into basicity of the acid. So molarity is 0.1, basicity is 1, so the normality will also be 0.1. That's why I said if the basicity or acidity is 1, then if the basicity and acidity is 1, then the normality will be equal to molarity. If it is more than 1, what happens? Say for example, I have 0.1 molar H2SO4 solution. What would be its normality? So according to the above formula, normality is equal to molarity into basicity. Since it is an acid, the basicity of sulfuric acid is 2. So molarity will be 0.1 into 2. Normality will be 0.2. So if you take 1 molar solution, it can also be expressed in normality. That means 0.1 molar is equal to 0.2 normal sulfuric acid. Are you understanding my point? Yes, students? So this is about how normality and molarity are related. So usually when we are doing qualitative analysis in the lab, we always prepare a concentrated solution or a stock solution. A concentrated solution is prepared or a stock solution is prepared. Stock solution means just like a juice extract, a concentrated juice extract, where you prepare a concentrate, you refrigerate it, and whenever is required you will dilute it according to the volume right? According to the person that they are going to have. Similar to that, here what we do, we'll prepare a concentrated stock solution and we'll dilute it from this. Dilution will be done. Say for example, I have 5 molar HCl solution. This is the stock solution or concentrated solution. So I have to prepare 0.1 molar HCl solution. How much I need? Say for example 100 ml. How much you will get? How do you do this? For that we make use of a formula which relate to the concentration and volume of one solution with the concentration and volume of the other. That is called as normality equation. That is N1V1 is equal to N2V2. What does it mean? So N1 and V1 are the concentration and volume of one solution, say solution A or solution A. N2V2 are the concentration and volume of solution B. So if you know any 3 terms, you can calculate the 4th term. So in this case, say let us take N1 as 5 molar, N2 as the required 0.1 molar, V1 I need to find out how much of this stock solution needs to be diluted to 100 ml. So V2 will be 100 ml. Right? Now if you substitute it in the formula N1 V1 is equal to N2 E2 normality equation, I need to find V1. So let us keep it on LHS and move all the other terms onto the RHS. So N2 is 5 into, N2 is 0.1, V2 is 100 divided by 5. So if you calculate this 0.1 into 100 by 5, you will get 2 ml of volume. That means if you dilute 2 ml of 5 molar HCl solution to 100 ml of water, you will get 0.1 molar. Remember, though I am using normality equation here, I am writing molar only because we know for HCl molarity and normality is same. So I can either express it in molars or normal, it is one and the same. Right? But in case if you take sulfuric acid, the normality and molarity changes. So in such cases, you cannot interchange the terms molarity or normality. You have to express it accordingly because the basicity will change. Thank you students. I hope you understood the concepts well. See you in the next session. If you want to take my classes, please call and book a demo session. Thank you.